So we are in the final lap of the course. We built up the main portion of the application, but then remember, there's this reward service application that calculates the reward points for us. As transactions come through the systems, as you deposit, as you withdraw, you're accumulating points, right? And those points or those events are going to be sent to a topic because we're going to utilize Kafka. Those events are going to be sent to a topic, and this reward service application is going to consume from the topic, and we're going to calculate the rewards points based on the activities or the transactions that a logged in user is doing with our application. And then from there, if this application wants to return information regarding the reward service back to the client, then they can go ahead and make a request to the reward service and it will return the current state of the rewards for that specific user. So, like I said, we're going to utilize Kafka and we're going to establish a connection between the main application and the reward service application. And then we'll be able to make a HTTP request to the reward service to retrieve information regarding the user. So cool. Let's get started on that. All right, so here's the flow of the Kafka message broker that we'll be utilizing between the funds application and the rewards application. So you have the funds application that will produce messages to the topic because the topic is going to be holding all the messages that the funds application produces. And then from the rewards application, it's going to consume all the messages from the topic. A hypothetical scenario is that we have a system, the funds application, that will send the events whenever a send or whenever a deposit occurs. And for every dollar that this funds application sends to the topic, that individual will earn 0.01 points. So 1%, which is not a bad deal. The goal is to distribute the work though. I do not want a monolithic system. I don't want the funds application to handle all of that, right? Because there may be a lot of transactions that are occurring and I don't want the funds application to have to deal with all of that. So I'm sending it to this topic where the rewards application can retrieve from the topic whenever it has the ability to do it. So I won't be giving a big overview of Kafka because this is not exactly what this course is about. So if you're interested in the internals, I do have a separate video on that. I'll leave a link in the description, but we'll still be going over step by step of how to create the producer, how to create the consumer, because we're going to need to create a whole nother application for the rewards application. And I'll need to create a consumer or the logic for the consuming portion to get the information from the topic. So I'll still be going over step by step on how to do that. But for more ingrained knowledge about Kafka, I have a separate video about that. So let's go ahead and set up Kafka on our machine. I'll be utilizing Docker for that. All right, so here I am back in the application and I already closed out some of the tabs because it was starting to look a little crazy, but we were able to get a lot of things done. I closed up the folders, and what I want to get started on is having the ability to spin up a Kafka container so that we can utilize Kafka. Within the funds application, which I'm in, I'll place a Docker compose to spin up an instance of Kafka and Zookeeper. Like I said, if you want a deeper dive into understanding Kafka and its components, check out my Kafka video, and I'll leave a link in the description. But within our Docker compose, we'll be utilizing the official Confluent Docker image for Kafka and Zookeeper. So for this approach, I will be utilizing a single node Kafka server with just one instance of Zookeeper and one instance of a broker. But remember for the future that a multi-node approach is safer due to the ability for scalability, because in a single node approach, the replication factor will be limited to just one, which means that all the partitions of a topic will be stored on the same node. The data can't be distributed across multiple brokers. Then there's the failover piece, right? Since we only have one node, we might face data loss in case a node goes down, right? If you're taking a multi-node approach, at least another node can pick up the slack. But in a single node approach, if one goes down, then we're kind of stuck. And then there's availability. Since we have a single broker, when the broker fails, well, we do have downtime, meaning the data won't be available. So for future scenarios that is not running locally, utilize a multi-node approach, not a single node approach, just to handle situations when it comes to failover, availability, and having the ability to scale. So what I'm going to need to do to spin up a Kafka and Zookeeper container is utilize Docker Compose, because with Docker Compose, it's going to let us run containers simultaneously. Now, before we did utilize a Docker command to run Postgres, which we could do, right? We can run Zookeeper, then we can run Kafka. but we could also utilize Docker Compose to run multiple services seamlessly. So I'm going to right click into this folder, the parent folder. I'm going to do new file, and we're going to call it docker-compose.yaml, right? And this is where the Docker Compose is going to be stored. And like I said, this is not a Kafka course, so I'm just going to copy and paste the Docker Compose, and I'm going to go line by line on what each line is doing. All right, so here is the Docker Compose, and the reason why this Docker Compose is so important, because for Kafka to run properly, Zookeeper has to run first, right? And having this all together on the same network is beneficial. Now, let me start off with the Kafka piece, and then I'll move back up to the Zookeeper to show exactly what is going on. And this is a YAML, so that it is going by key and value. So you have up top the version and the version number, which is in a string. And then you have the services key that's holding the different services underneath it. So you have an instance of Zookeeper, which I said is using the image from Confluent, right? The Docker registry from Confluent. And then the same thing for Kafka, right? It's also being retrieved from Confluent. But you can see that the services are right below. So you have Zookeeper, and then I have the Kafka instance running here, which I just called broker, right? But they're all within services. And like I said, let me start off with Kafka. And right here, the image is essentially the blueprint on how the container will be built. And it is being built based on the instructions from the Confluent registry, right? This is the official Kafka image from Confluent. And the next line is just a container name, right? If you don't provide a container name, it's going to provide a random name that doesn't really help you identify what the container is doing. So in my case, I provide a container name of broker for this Kafka broker. Then I'm defining the ports. You can honestly move this to the bottom as well, it's depending on you. But I'm saying I'm exposing the ports on 9092 internally and externally. And if you have IntelliJ, if you hover over, you can see that it's showing that from the host, it's exposing on 9092, and from the container, it's exposing on 9092. And then a very important piece next is depends on, because this Kafka container is going to be dependent on Zookeeper, right? Zookeeper has to run first before this Kafka container can be officially built. So with this depends on key right here, and informing Zookeeper as the container that is depending on, is going to wait until Zookeeper is fully built before starting the process of building this Kafka container. So this is important, right? This depends on is very important in informing what service this Kafka broker is dependent on, or this Kafka container is dependent on. And then right below here, you have the environment variables. So these are variables that we can adjust to make sure that Kafka is running in the way that we want it to, and is able to connect to the Zookeeper container that was already spinned up beforehand, right? Just like with our Postgres instance that we did earlier, we could define these environment variables to build it in the way that we want to. So with Postgres, we define the username, the password, environment variables like that. But in this case, we're defining things like the broker ID, which is a unique and permanent name for each node in the cluster. In this case, we're taking a single node approach, so we only need to define one ID. So I just defined it as one. But if you had a multi-node approach, it'll be different, right? But since this is a single node approach, it's just defining that unique and permanent name for the node, for this single node. Then you have the Kafka Zookeeper Connect, which, as the name implies, just helps connect to the instance of Zookeeper that is running. We provided the service name, which is in this case Zookeeper, and this only works because this is within the same network, right? By default, when you use Docker Compose, it creates its own virtual network that wraps these services together, and we're able to utilize the name of the service to define where this service is being ran from, right? So it's able to see that Zookeeper, okay, where is Zookeeper? Well, Zookeeper is running here, right? It's running it within the same network, and it's going to provide that host name because we're able to see it from the same network. So that's the reason why I'm able to just put Zookeeper here as the host name, and I'm passing in the port which we exposed on 2181, which we're able to see here. We see that we're exposing 2181 from the host and from the container, and I'm able to connect to that instance of Zookeeper by specifying that port. So that's the Kafka Zookeeper Connect. Like I said, Kafka is dependent on Zookeeper, so this is only going to work if Zookeeper is running first. And then we have the Kafka Listener Security Protocol map. This just defines a key value pair for the security protocol to use per listener name. So in this case, I'm defining plain text for the key and the value. And then we have the Kafka Advertised Listener, which just makes Kafka accessible from the outside of the container by advertising its location on the Docker host. It can be comma separated based on the amount of listeners, and you just got to specify the host /IP, right? But in this case, it's localhost, so just defining the host and the port, which is 9092. So this is the metadata that is passed to the clients. And then lastly, we have the Kafka offset topic replication fact. Now, this is really required when running a single node cluster, right? We're running a single node approach, which, like I said, is not recommended for production-based applications. You want to make sure that you have the ability for your broker to have availability, fault tolerance, and the ability to scale. But in this case, we are running a single node approach. And if we are running a single node approach, we do have to define the Kafka offset topic replication factor. And I'm defining it as 1. If you're utilizing a 3 or more node approach, then we can just leave the default value. But in this case, it's a single node approach, so we have to define this as 1. So that is the Kafka piece. We have the environment variables. We showed that it's dependent on Zookeeper. We have the ports that we're exposing it on. We have the container name, and we specify the image, right? The instruction on how to build this Kafka container. And then we can move on to Zookeeper, right? This is pretty much what Kafka is dependent on before it can actually run the Kafka piece, right? We have the official image of where it's grabbing it from. It's grabbing it from the Confluent registry. It's the official Zookeeper image. Then we have the container name. We're defining it as Zookeeper. And then we have the environment variables. First, we have the Zookeeper server ID, which is just a unique identifier for the specific Zookeeper server. Then we have the client port, which in this case is running on 2181. Then we have the Zookeeper tick time, which is like a health check, right? It's going to check every 2 seconds. Right now it's in milliseconds, right? It's being stored in milliseconds, but 2000 milliseconds is 2 seconds. So it's going to check every 2 seconds to see that everything is okay and the connection is okay. And the timeout is going to be based on double of the tick time. So if it's unable to establish a connection within 4000 milliseconds or 4 seconds, then we'll time out. That is what the tick time is utilized for. And then we have the ports that we're exposing it on from the host and from the container, which is 2181. Now, there are a lot more environment variables that you're able to adjust based on how you want it to be adjusted. You just have to check out the official Confluent Docker registry for Zookeeper and Kafka, and I'll leave a link in the description for that as well. These are the environment variables that we'll need to actually get it running properly. But there are a lot more that you can adjust to make it fit exactly how you want it to fit. So now that we have the Docker Compose structured as we want to, we just have to run it. Right? We have to make sure that we run this Docker Compose so that Zookeeper can be created and then Kafka can be created. So I'm going to go over to the terminal and we can get that done. So here I am in the terminal and I'm in my funds app parent folder, which is holding the Docker Compose file. That is very important because if you're not in the same directory as your Docker Compose, then the Docker Compose command is not going to work to run the Docker Compose. So make sure that you're in the proper directory of where that's being housed. And let me confirm that Docker is actually running. So let me do Docker PS. Okay, it's running. I'm able to run the command, although there are no containers running right now because I did stop the database. You probably do see your database here if you are running it and any other containers that you're running, but it's working as expected. So let me clear that out. And first of all, let me make sure that I see my Docker post. So by doing ls, I can see that I'm in the proper folder structure. It's here. All right, let me clear that out again. And then what I need to do to run the Docker Compose, to actually spin up the containers, I could do Docker Compose up, right? And this will start the command of building the containers within that Docker Compose. Another thing that I like to do, because if you don't utilize this flag that I'm adding, which is -d, then it's going to run all the logs within this terminal, and I don't usually like that because then I lose command of the terminal and I got to open up a new one. But if you don't mind that, you can do without the -d. That's fine. -d just means detached, just short for detached. So you can remove it if you don't want that. But if you want it to run in the background and you still want access to your terminal and you don't want to see all the logs as things appear, then you can use -d, which just means detached, and press enter. And then you can see that it starts the process of building those containers. And you can see that the container Zookeeper was created and started, and then afterwards Broker was created and started. So if I do Docker PS, I should now see that yes, Kafka is running and Zookeeper is running, and we're good to go. And you can see that it's running on the ports that we expect, 9092, using a TCP port. So now we have the containers that we need to utilize Kafka within our application. We just have to get the dependency to interact with it. So that's what we'll be doing next. All right, so now that the Docker Compose is done and we created the containers for Zookeeper and Kafka, we can go ahead and add the dependency we'll need in this application, and that is Spring-Kafka. All right, so I'm going to go into the pom.xml, and what I'm going to do is right below this last dependency here, I'm going to paste in the dependency we'll need, which is Spring-Kafka, and the group ID is org.springframework.kafka. And I'm going to let Maven get that by loading the changes. Alright, so now that Maven did its thing and got the dependency we'll need, which is Spring-Kafka, we can now start the process of configuring our topic. Because yes, we have Kafka running, but we still need a topic to send the messages to, right? Because this application will be producing messages to a topic, and the second application, which we'll be making soon, will be consuming from the topic, but we actually still have to make the topic. So to do that, it's pretty simple, and I'll show you guys that. So in this config, we're going to have to make a new file called Kafka config, and that'll be a configuration file that creates the topic for us. So I'm going to right click here, do new, call it class, and we do Kafka config. And just like with any previous configuration file, I'm going to need an annotation of @configuration. Import it. And now we can start the process of creating the topic utilizing code. So to do that, it's simply just going to take a function. And we can do that pretty easily here. So I'm going to do fun. I'm going to call it transaction topic. And I expect this to return a new topic, which is going to come from the dependency that we just imported. And with this function, it's going to create a topic and return an instance of that new topic. Now, creating a new topic can be done from the command line, but I'll be utilizing code in this case, just to show you guys how you can even do it. And I forgot parentheses here. So I'm going to open this up, and above here, I'm going to use another annotation just so that Spring knows to create this topic when the application starts up. I'm going to use the @bean annotation. And then what I'm going to do here is I'm going to start the process of returning a new topic utilizing the topic builder that is provided through the dependency that we imported, which is the Spring-Kafka. So import that, and the first thing that I want to define utilizing this topic builder is the name. And the name of this topic is going to be transaction-topic. So that's simply just the name of the Kafka topic. And the second thing I want to define is the partitions, right? What is partitions? Well, partitions help distribute the data. The more partitions, the more you're able to distribute the data, the more you're able to do parallel processing. So like I said, I'm not going to dive too deep into Kafka because I do have a separate video on the inner workings of Kafka and what is partitions and what are the settings that you can change for Kafka. But when you think of partitions, just think about the splitting of data, right? And the ability to process data in parallel. So in this case, I'm only going to make 2 partitions, right? And the second thing I'm going to provide is replicas. Just as the name implies, it's dealing with replication, right? Specifically the replication factor. We're specifying the replication factor. So meaning each partition that we have will have the amount of replication that we provide. So in this case, I put 2. So that just means that for each partition, there'll be 2 replicas. And this is great for fault tolerance. So if one partition goes down, well, guess what? We have a replication of it. So that should be fine. So it's perfect for fault tolerance. And then afterwards, I'm going to do .build, and that will return the instance of a new topic. So it has the name, it has the amount of partitions for that specific topic, and how that data is going to be distributed. It has the replication factor for each partition, and after that, we built it and returned the new topic. So when the application starts up, it's going to create a new topic called transaction topic. And like I said, this can all be done from the terminal using Kafka commands, but this can also be done as well. And you can also create multiple topics, but in this case, we only need 1 topic. But if you want to learn how to make additional topics, I do have a separate Kafka Springboot video for that as well. So I have multiple videos on Kafka that you can utilize. So now that we have the ability to create a topic, I want to be able to define how the message will look like when it reaches the topic, right? How is that message going to be structured when we send it to the topic? So to do that, I'm going to go ahead in this models folder and I'm going to create a new package and I'm going to call it events because this will store the models for events. And I'm going to create a new Kotlin class and it's going to be a data class and I'm going to call it transaction message. So when a transaction occurs, I'm going to send that transaction to the topic in this structure that I'm going to define. So the first one is going to be the transaction ID. This is just a unique ID for each transaction going to the topic. So transaction ID, and none of these are going to be nullable. They all have to have a value. The second one will be user ID because we have to know the user that this transaction is associated to, right? And then we'll have transaction type because based on the transaction type, we may process it, we may not. So we have to know the transaction type. Or even defining how many points the individual may get based on that transaction. And then we have the amounts, right? That's just going to be helpful when we need to define how much reward points, and this got to be a double. How much reward points is this individual going to get based on the transaction type and the amount? So that's really all we need. Transaction ID, user ID, transaction type, and the amount. So before getting started with actually producing a message, I want to go over how it will actually be done. We'll be utilizing a Kafka template to send messages to the topic we just created. The Kafka template will wrap a Kafka producer and provide convenient methods to send to Kafka topics, whether it's the topic we just created or any other topics that you choose to define in the future. The method that we will utilize to send a message to the topic will need 3 parameters: the topic name, the key for the message, and the value of the message, which the value of the message would just be the transaction message that we just created. To use the Kafka template, we're going to have to configure a producer factory, and I'm going to make a configuration file just for that, right? Because we're going to have to configure a producer factory and provide the template constructor that producer factory. And the producer factory is essentially going to contain all the configurations of the producer, including the type of serialization, which is dependent on the type of message. So in our case, it's going to be a JSON, right? Because when we place a value on a Kafka topic, it doesn't store exactly how we expect, right? It's stored in binary, right? 0 and 1s. So we serialize it, we place it onto the topic, it's in 0 and 1s, and then the consumer consumes it and then deserialize it based on the serialization. So in our case, we're going to serialize it as a JSON, and when the consumer deserializes it, is going to deserialize it as a JSON. So as it was sent is how the consumer will receive it. And all that information is going to be provided in the producer factory, right? That's going to contain all the configurations. We're going to inform Kafka that it's going to be a JSON serialization, and then when the consumer consumes it, it's going to know to deserialize it using a JSON deserialization method. And the key, we define the type of the key as well, and the key will be a string. So I hope that makes sense. I just want to give a little introduction on what we'll be doing and why we're doing it. But yes, this is all going to be wrapped in a Kafka template, and within the Kafka template is going to be the Kafka producer, which will contain all the configurations needed to send information to the Kafka topic in the format that Kafka expects. Because really, Kafka doesn't really care what the data is, right? It just needs to be serialized, right? 0 and 1s, and then whoever chooses to consume it, well, they'll have to deserialize it based on the type that it was serialized as. And yeah, let's get started on the Kafka template. All right, so here I am back in the application, and one thing I'm going to need to do first is I'm going to need to go into the application.properties, and I'm going to need to define a new property that will contain the information regarding the Kafka server. So I'm going to do funds underscore app.kafka.servers underscore config, and I'm going to define it as localhost 9092. So if this ever changes, well, all I got to do is change it here, right? And it will reflect in the producer portion of the application. So I know where I'm sending the message to. So this is why it's needed. So now I can go ahead and create a new configuration file, and I'm going to call it Kafka producer config. And it's going to be a new Kotlin class called Kafka producer config. And you already know you're going to need the @configuration annotation. And I'm going to go ahead and paste in the value that we just placed into the application.properties utilizing the @value annotation like we did previously. So you paste that in, and I'm going to need to import the @value annotation, and it's just importing the funds_app.kafka.service_config that we just set in the application.properties here. So this will hold the information regarding that Kafka server. So now we know where to produce the messages, because like I said, we're going to need to define the configuration for the producer here, and it needs to know where to produce the message to. So underneath here, I'm going to start the process of defining the producer factory, which is going to hold information regarding the producer, right? It's going to be the producer configuration. So do @bean, because we're going to need to generate this when the application starts up, and it's going to be a function of producer factory, and we expect it to return an instance of producer factory, and we're going to need to define how the message or how the key value is going to look when we're producing a message. So the structure of that. So the key, and I said a string, but really it's not going to be a string. It's actually going to be a long. So I take that back. The key is going to be a long, and the value is going to be a transaction message, which we just defined. And then within here, we can start defining the configuration properties that's going to be returned by this producer factory instance. So first, I'm going to create a variable called config props, and it's going to be equal to, or it's going to be of type of mutable map, and it's going to be a string for the key and any as the value, because we're going to have different types as the value, so we're going to have to use any in this case, and it's going to be an instance of a hash map. So within here, I'm going to do config props and define producer config, and we can start defining the specific keys, because the producer config is coming from the Kafka dependency that we imported, and it has different keys that we can provide. So if I do dot, you'll be able to see all the different keys that we can utilize for the configuration properties. So for the first one, I'm going to utilize bootstrap server config, which is simply just going to be equal to the Kafka bootstrap server variable that we defined in the application.properties, right? Remember this localhost 9092? Well, we need that so we know where to send the message off to. So that's where the server is going to be exposed on. So we're going to provide it here as the Kafka bootstrap server config. Then the second property I got to define, and I'm going to do config props. The key is going to be producer config dot key serializer class config. That is a tongue twister for me, and it's going to be long serializer, and I'm going to do class.java. Cool. And then the second one is going to be producer config dot value serializer class config, and this is pretty much going to say what is the value going to be, and how is it going to be serialized. Well, it's going to be, we're going to be utilizing a JSON serializer, and it's going to be class.java, and I got to import that. Then go ahead and return a default Kafka producer factory, right? And that's going to be a long, and we already know that it's going to be of type transaction message, and we'll define in the constructor, we're going to pass in the configuration properties that we just set. And in that, it will return an instance of producer factory with the key value of long and transaction message. And then from there, we can define the Kafka template, which is what I talked about, which will provide us with methods to easily produce messages, because it's essentially going to be a wrapper for the producer. So I'm still going to use the bean annotation, right? And then it's going to be Kafka template, and then provide the type that is going to be returned is going to be Kafka template, and is going to be of type long as the key, and the value is going to be transaction message, and we're going to return an instance of Kafka template. And remember what I said, as the constructor value, you got to pass in the producer factory. Right. So now we'll be able to send a message to our topic, and the key is going to be a long, and the value is going to be the actual transaction message. And with this bean annotation, is going to allow us to inject the Kafka template where we need to use it to produce a message, so it can be utilized in our fun service. When we're done processing a transaction, we can go ahead and use the Kafka template to send a message to our topic. Or a cleaner approach will be creating a Kafka producer service, which I'll be doing, and then creating a function called send to then, you can pass in parameters to then send a message to the topic pretty easily. And why that'll be useful is because then I can just make it a little bit generic, where I can define the topic name as a param and the key and the value, and that'll be easy in for future cases where I may need to utilize a different topic for different types of events, right? So maybe I might have one extracted for a deposit, or have one extracted for withdrawal. All I would have to do is change the topic. Or even cleaner approach will be creating a Kafka producer service, which will have a send function defined to allow us to send a message to a topic name that we provide in the parameters. So that's exactly the approach that I'll be taking. So I'll be creating a Kafka producer service to handle sending, utilizing this Kafka template that we injected into the service itself. So let's get started on that. All right, so let's go ahead and create that Kafka service that I was talking about. I'm going to go in the service folder and do new Kotlin class, and I'm going to call it Kafka producer service. All right, then I'm going to give it the usual annotation of @service, import it, and then within the constructor I'm going to inject the newly created Kafka template, which is going to allow us to utilize the methods, specifically the send method is what I'm going to need to produce a message to the topic based on the topic name that we provide. So I'm going to do private val Kafka template, and it's going to be of type Kafka template. And then I got to define the type of the Kafka template, and I'm going to say it's going to be a long, and then for the value is going to be transaction message. Now within here, I'm going to define a method called send, and that's going to send the message to the topic name that we specify. So it's going to be function, and it's going to be send, and the first parameter is going to be topic name, and it's going to be of type string, and then there's going to be a key of type long, which in this case is really just going to be the transaction ID. That is going to be the key that we utilize to make it unique for each type of message that we send, and the value is going to be the transaction message. Then open that up. All right, so now we have the parameters that we need to send a message to the Kafka topic. And we're going to utilize the Kafka template that we injected into the Kafka producer service. So to do that, we can do Kafka template and easily use the .send. And as you can see, there are other methods that we can utilize through the Kafka template, but I want to utilize send. And I can pass in the topic name as the first parameter, the key for the second, and the value, which is the message, as the last parameter. Now you probably think that is all, right? This is going to send it to the topic. Everything is well. We don't have to worry about anything else. Well, that's false. Because this send is going to return a completable future, which holds the future result of the asynchronous operation that was just done. Because this is asynchronous. This is not synchronous. This is not going to wait for the message to be sent and then continue on to the code afterwards. No, this is asynchronous, meaning that it's going to run on a different thread and it's going to return the results at some time, right? We don't know that time. It can be within a second. It could take a little bit more. It could take a little bit less. We don't know. It's asynchronous. It's running on a different thread. But luckily, there is a thing that we can utilize to know when it's done. We can use the when complete function, which will let us know when the asynchronous action is complete. It also has a callback to let us know if an exception occurred. So we're going to utilize that for this completable future that is being returned from the send function here. And I'm going to bring this down just to make it look cleaner. And I'm going to use the dot when complete. And I'm going to open up some curly braces. And I'm going to specify the two things that we expect, right? Which is the result. And if there's an exception, then it's going to be stored within this exception, right? And then we can use the arrow to then write the logic on what should be done with these variables, right? Because the result is going to hold the result, if it actually went through, is going to hold information regarding the message that was sent, such as the topic, the partition that it was stored on, the offset. So first we have to actually check if an exception occurred, though. And to check if an exception occurred, well, we got to see if there's actually a value within this exception. Now, what we can utilize to check if everything went through properly is a simple if statement, right? If and else, right? Because we can use if to check if exception is populated, right? And if exception is equal to null, that means there was no exception. So within this first if branch, if it's equal to null, then that means it's succeeded and we can handle the successful messages here. Then we have the else, right? If the exception actually has something within it, then we have to handle the cases where the message failed, right? Whether you want to retry, because it is possible to retry in Kafka, but I'm not going to go over it in this course. I'll probably make a separate video on that, but it is possible to retry. That's one of the amazing things about Kafka, is that there is retry capabilities. You can even specify how many times you want it to retry before giving up. And there are other things you can log, which I'm going to do. I'm going to print out, information regarding that exception for monitoring purposes. So there's a lot of things you can do in cases where it fell, but it will have to be done within this else branch. So success will go above here, and exception logic will go within here. I'm not going to do anything fancy. All I'm going to do is, okay, it went through properly, then let me just print out that it went through properly. And since I know that it went through properly, I know that there's going to be information within this result variable here, right? Because it actually went through, and there should be information regarding that message that was sent to the topic. So I can get information from this result variable, such as the topic, the partition that it was placed on, the offset, which is the positioning of the message in the partition. All that information is going to be within this result. So let me utilize that really quick, and I'm going to use some string templating. So message successfully sent to topic, and I can open that up and inject the variable into it. So I can do results. Let me do a little save call to check if it's actually has a value within it, just in case it's null, but I'm pretty sure it's not null because there are no exceptions. And then I can get information regarding that record, right? So the record metadata, and I can do dot, and I can get information regarding that result. So I can get the topic, get the offset, the timestamp, whether it has an offset or not. Let me get the topic first, and I have to use a save call there too. All right, and then I'm going to also log the positioning of the message within my topic, right, within the partition, right? So I'm gonna do at the offset, and I'm gonna open that up again, and I'm going to do result record metadata, and then save call again, and then get the offset. So if it went through properly, no exceptions, then we're going to print out information regarding the result, such as the topic that it was placed on and the offset, and it's actually a call, so you got to open a parentheses here. And if you want to get the partition of like where it actually was stored, because if you have multiple partitions like we do, right, because we created in the Kafka config, we created 2 partitions, so it can either be placed on the first partition or the second partition. So you can get information regarding that partition by just doing dots, and I believe it's partition, right? So this will grab the partition that it was placed on. But in my case, I'm just going to grab the offset. So that's simply the positioning within the partition. So whether it's the second message that's being ready to be consumed or the first one, that's the offset. And then within this else branch, we can print out that there was an issue. So I could put message unsuccessful due to, and I can print out the message because we have access to it by doing exception dot message. So cool, that's how we handle the asynchronous call that is utilized when using send from the Kafka template. So now we can integrate this Kafka producer into our services to actually send to the Kafka topic. So for example, in our fund service, when a specific transaction occur, we can now utilize the send to send a message to the topic so that the user can get points, right? Because the consumer is going to consume from that topic and provide points based on it. All right, so let me head over to the fund service, and I can go ahead and add the Kafka producer service so we can utilize the send method within here. So I'm going to do private val Kafka producer service. I can add that in. The next thing that I want to add is I want to add a constant value called transaction underscore topic, and I'm going to make that equal to transaction dash topic, which is the topic name that we will be using because we created this topic in the Kafka config, and I can go and you can check that it's there. So we have this topic name that we'll be utilizing to send the message from this fund service, because remember the send method needs a topic name. Now, as a disclaimer, I wouldn't recommend injecting the constant value like this directly into the file. You could use the application properties, or like I discussed before, you could have a vault that stores all the keys and values that you need for your application. But because of the nature of this application, the fact that we're only going to use one topic, and I know I'm only going to use one topic, that's the reason why I injected it directly. But as a disclaimer, you probably want to use either the application properties or a vault, because you never know the direction of your application, right? Maybe in the future you want it to be a little bit more dynamic in the case where you want to change the topic, right? You're migrating to another topic or using multiple topics, right? So having it just constantly within the file may not be a good approach, but just for this demonstration, I'm injecting it into the file directly. So now that we have the topic name, we can utilize the Kafka producer service and the send method within the Kafka producer service to send messages to the topic so that the reward service, which we'll be creating soon, will consume from that topic. And we just have to place that send method within the proper methods. And the 2 methods that I want to place it into is the handle deposit and the handle send. Because hypothetically, in this situation, we have a promotion going on, right? We want individuals to deposit money into our funds application, right? So if you deposit money into our funds application, we'll provide you some reward points. And whenever you send money to somebody else, right, that means that other user may have to sign up and you will get reward points for that, right? Now, the best place to put this send method to me will be right after saving the new transaction and saving the account. Because if any issue arises while attempting to save the new transaction or saving the account, we know it's going to roll back this information that it tried to save because of the nature of transactional. But if everything goes through properly, it'll get to this next line and we'll have access to the new transaction that was saved, right? This new transaction, after the save, is going to be populated with the ID of the transaction. So then we can utilize that transaction ID to send a message to our topic. So we can do new transaction, and we could do dot ID, and we're going to do a safe call here because ID can't be nullable and Kotlin doesn't like nullable. And then we're going to utilize the scope function that we utilize a lot in this course, which is let. And if this is not null, if this ID value is not null, which we expect it not to be null because we just saved it and no issues arise because we got to this point. But like I said, Kotlin gets angry if you don't check. But once we confirm that it's not null, we can go ahead and let Kotlin run this piece of code within it. So I'm going to do Kafka producer service.send, and then the first value it expects is the topic name. So we have the transaction topic, which is holding the value of the topic name. We're going to need the key, which in this case is going to be the ID of new transaction. And we know we can get access to this ID because we're using the scope function of let. We have access to this ID by using the variable of it, right? Because it is just an instance of the ID that we're checking for, right? We're checking to see if it's null or not. If it's not null, then it's going to let us have access to that value by using it. So we're going to pass that as the key, and then the value would just be a new transaction message. And we can just bring this down to the next line to make it a little bit more clearer. And the last line is going to be an instance of transaction message, which I'll pass by just opening it up and then passing the constructor values that it expects. So the first thing that we're expecting for the transaction message is, well, the transaction ID, which we have by using it. And then the second value we'll populate for the transaction message is the user ID, and we'll pass in user ID. We know it's a valid user ID, and the user ID passed through the param. We know it's valid because we did the checks. We checked that it's associated to the proper account. We checked that the user actually even exists based on that user ID. So we know that it's a valid user ID. Then we have the transaction type, and that'll just be equal to deposit. So we can do transaction type dot deposit, and then the amount would just be equal to the new transaction dot amount. All right, cool. And if you want to be sure from this user ID, you can also use new transaction dot user ID. So you have three ways to getting the user ID. You can grab the user ID from the user itself. You can grab it from the new transaction. You can grab it from the param that was passed. All of that is valid. It's really up to you. But we're now able to send that message over to the topic. And just to have a check on if it actually is null for some reason, then we can do a Elvis operator and run a snippet of code if it actually is null. And we can just print out a message informing that we're unable to send transaction message to the topic for user, and we can inject the user ID here using templating due to invalid transaction ID. So this will only fail if the transaction ID is null. So that's the reason why I'm printing that out. And just for monitoring purpose, hypothetically this is a logger, then you'll know exactly what transaction fails. And if they ever reach out and wondering why they didn't receive any reward points, then you know exactly where and when that issue arose. So if you're utilizing a logger, the logger will have things like the timestamp, or we can even inject the timestamp here, but you should honestly use a logger, which I'll show later on how to do. But you'll have the timestamp and you'll have the user ID in there, so that'll help a lot. So yeah, that's how you handle sending a message to the transaction topic utilizing the newly created transaction. And honestly, I'm just going to copy this, and we can provide the same thing to the send or handle send method. So I'm going to go over to handle send, and right under here, I'm going to place it. And the person that's going to accumulate the reward points is the person sending the money, not the person receiving it, but the person sending the money. So here I'm going to use the from transaction, right? And it's going to be the same transaction topic, and the user ID will be the from transaction dot user ID, and the amount will be the from transaction dot amount, and the transaction type will be send. And same error, right? Unable to send transaction message to the topic for user, and you can specify the user ID. And if you want to make it more specific, you can even place the type of transaction. So I'll do transaction type and specify here the transaction type. So I'll do transaction type dot sent. And honestly, I'll probably just copy this over and use the same thing for deposit, just to know for debugging purposes where exactly do we need to check this issue. Now we have the ability to send a message to the topic to accumulate rewards when the reward service consumes the message from the topic, when a user deposits, and when a user sends money. And the person that's going to accumulate points when they send money is the person that's actually sending the money, not the person that's receiving, right? Because you're receiving money. What's going on? You're not going to get points for that. But the person that's sending the money will receive the points. So now that this is done, what I'm going to do is I'm going to go to Postman, deposit some money into the account, and see what happens within our Docker logs for our Kafka instance to see if it's processing the message properly. Right? Is it actually sending the message to the topic? And does the instance in Docker actually see it? Does our container see that the producer within this funds application, is it sending the message properly? So we'll check that in the Docker logs. All right, so actually I usually am very honest about my mistakes. I want to go over one mistake that had me scratching my head for a pretty long period of time. And that's in the Kafka producer config. And I just want to show this mistake just in case anyone else is experiencing that error, whether they followed me importing this issue or whether they did it by accident just like me. And that's within this Kafka producer config, and that's specifically for the JSON serializer. You have to be careful when importing. This is not the correct JSON serializer. This is coming from Jackson, and the Kafka producer is not going to understand that, right? There's a JSON serializer specifically from Kafka that we have to import. It is not from Jackson. It's specifically from Kafka. So I'm going to remove this. Honestly, I don't have to comment it out. I'm going to remove it, and I'm going to import the proper one. So if I click on this, if my IntelliJ stopped being so slow, I can import it. And before, as you can see, it's the first one that pops up. And the one that I need the most is actually at the end, which is coming directly from Kafka. It's coming from kafka.support.serializer. And that is the proper JSON serializer that I need. And that's the reason why I was scratching my head for so long. Like, why is this not working? Why is it not sending the message? Well, it's because I'm using the wrong JSON serializer. So use that one for the value serializer, and you should be good to go. And also make sure that you're using the right long serializer, which, as you can see, is coming from Kafka. We're good to go on that end. And as a token of my appreciation for understanding, I'm going to go into the application.properties, and I'm going to show you guys one more thing. Within here, you can adjust the logging level for Kafka. So if you want to see more information regarding Kafka and what is occurring, you can add this piece right here, logging.level.org.apache.kafka, and put the logging level that you want. I'm running this locally. I want to see as much information as possible, so I'm going to run it as debug because I want to see what's occurring. I want to see when Kafka creates a topic. I want to see when Kafka sends information to the topic, and even on the consumer side, I want to see when Kafka consumes that message from the topic. So all that information will be shown if you adjust the logging level. And for production, obviously, you wouldn't want to put as much information. You would adjust it based on your needs. So now I can go ahead and run this, and it should work as expected. So let me press the play button, and I'll be back when it's fully built. All right, so it's fully built, and one thing that I want to show is that it actually attempted to create the topic if it's not already created. So what I can do is I can search for the name of the topic that I established in the Kafka config, and that is transaction topic. And I ran this before, so it's going to say topic exists already because it already existed because I ran this before. But if you didn't run it already, you'll see the process of it creating the topic, and it'll utilize the admin client to create the topic, right? It's going to show information regarding the Kafka broker, like how many partitions you're attempting to create and how many replication factors you're attempting to create. And by default is 1, but in our case, we're setting it to 2. And right here, we can see that we have information regarding that transaction topic, right? So there's a lot of information to process through, but if you already know exactly what you're looking for, you'll be able to find it here, or you can even go into your Docker container and it will show similar information. So here I am in the Docker desktop. If I go and open this up and I go into the broker, It's a lot of information to go through, but what I'm specifically looking for is the transaction topic, right? And up top, I can already see that is creating the transaction topic with the configuration that is passed through, and it's going to attempt to create the transaction topic with the replication factor that we provided and the partition amount that we provided. So if you want to go through this and see the process of how it's creating it, then you could do that as well. But I just want to show you guys that you can also view the logs in your Docker instance as well. Now here I am back in Postman, and I'm going to go ahead and log back in again so I can get a fresh token. And I'm going to go to deposit, and I want to try deposit to see if it'll work, to see if the producer will actually send the message. If it goes through, that means the producer is able to send the message, and if it doesn't, then it's going to throw an exception. It's going to inform us that it's unable to send it and why. So let me go ahead and press send. I see 201. Let me bring this up. So I see the transaction. It went through, and let me get the transactions. All right, so I see there's $100 in my account. Let me go back to the logs to see what occurred. So here I am back in the application, and luckily we printed out information regarding whether or not the transaction went through to the topic, and I can see here that the message successfully was sent to the topic, and it was given the offset of 0 because it is the first item in the topic. And I can send another one to confirm that the offset is going to continue to increase, especially with the fact that nothing is consuming it. So there is going to be a line that occurs when it comes to these inside of the topic. So let me send one more message, and we can see that. But we can also see that the message was successfully sent, and that we have information being sent to the transaction topic properly. So here I am going to send one more. I'm going to deposit 100, and I can see that it went through. And here I am back in the application, and I can see that the offset now is 1, right? Because this is going to be the second item. It does start at 0, but it's going to begin to increment, right? It's going to work as a line, right? And we see that it was successfully sent. So now we have the ability to send messages to the topic, but now we have to be able to consume that information. So what I'm going to do is I'm going to go to Spring Initializer, and we're going to begin the process of creating the new application so that we can process these messages that are on the topic.